In stats, we started the probability chapter, and we started by defining probability and the law of large numbers. So first off, when you calculate a probability, it must be a number between 0 and 1. I think otherwise you know what that definition is saying. So number of outcomes you're interested in divided by the total number of possible outcomes. Law of large numbers, this is saying that the proportion of whatever that outcome of interest is, the number of times it occurs, over the total number of trials is going to be very close to the value in question's probability. So for example, if I flip a coin 5 times, I might get heads 5 times in a row. I might. If I flip that coin 1,000 times, I'm probably not going to get heads 1,000 times in a row. Like, yeah, there's a chance, but it's approximately 0. It's just not going to happen. So law of large numbers is saying that you see in these two graphs, proportion of heads when I flip a coin, that proportion is slowly approaching 0.5, which is the true probability of getting heads on one toss. So notice on the graph on the left, it's erratic, it's all over the place. The person got a few heads in a row, got a few tails. If you look at the graph on the right, especially in this region right here, they were getting a lot of heads in a row. I mean, they did have a little drop right there. But then quickly it drops off and they get a bunch of tails in a row. So over time, let's see, in that paragraph, looks like they tossed it 500 times. After about, I don't know, the 100th toss around here, it was really close to 0.5. Then it got real erratic again, but then after that, it's very close. Who knows what that scaling is there? That could be 0.49, 0.48, but it is close to 0.5. So law of large numbers, back to the definition. So as we do this thing many, many times, that proportion is going to be approximately equal, to the true probability. All right? So feel free to hit pause and read through this if you want. I basically talked you through it. All right, something else that you need to be able to do is interpret your probability. Many times I think of it as long-run relative frequency. So, if I do something one time, there's just a probability. But if I do something many, many times, this phrase, in the long run, is a good phrase to use because that tells me that you're thinking law of large numbers, that it's going to approach 0.5. It's going to be very close to 0.5. So that phrase is handy to use. That quote right there is a good interpretation of the probability of getting heads. A simulation is when you take that chance game, that chance situation, and you do it many, many times. So there's the definition, but here is a better definition. And that's how you perform a simulation. So we have this situation with parking down below. That's our question of interest, like was it done fairly, this whole lottery process. And we're going to do a simulation to determine if it was done fairly. So in the simulation, we're going to do the process many times. Then on the do step, we're going to actually do it. Many times on a real AP FRQ, they do the do step for you, and you just need to know how to interpret the data. And then you got to make a conclusion about it. So this is a 4-step process: state, plan, do, conclude. When you're trying to plan out something that you wonder is done fairly in this case. Maybe you're looking for a significant value. Maybe you're doing a hypothesis test. State plan do conclude is a good 4-step process. So down here, maybe hit pause and read through it. And it looks like we have 95 students. They did the lottery, and 2 students from the AP Stat class who did the lottery, like conducted the lottery, right up here, were drawn by a person in that class, were chosen. So this sounds like the lottery was rigged. Maybe somehow the person that drew names drew people from their class, something like that. We have 28 people in the class, and we need to do a simulation to test if it was done fair, if this was plausible, like believable results. Yes, there's a chance, but was it likely? All right. So I typed a question there. Is it plausible that it was carried out fairly? I'm going to write a follow-up question just a little bit more detailed. Is it plausible that 2 AP Stat students were selected for the golden parking lottery tickets? Let's say tickets. So that's my subject of interest. All right, we're testing for that. To plan it out, it is very, very similar to drawing a random sample, because I need to use some kind of random procedure to simulate it. So let's start out with the sampling frame. Number everyone. One, 295. So now we have a sampling frame to work with. Use a random number generator. To sample or get 2 numbers from 1 to 95 without replacement. So that means, I think you know what it means, but if I get a repeat out of those 2, so if I got a 5 and then I get another 5, then I need to do the whole trial again, all right? So without replacement. I also need to know what to do with these numbers. Like what are these numbers going to symbolize? Because on the do step and on the conclusion, I need to say something in regards to likelihood. Because if I just get, for example, on trial 1, if I get student number 6, and then I get student number 28, versus on another trial, I get student number 27 and student 91, those are 2 completely different results, right? Like, who are those students? We need to define our numbers. So I would say somewhere in those first couple of sentences, who the stat students are. Let numbers, you can decide this in advance, and then it's not biased. 1 to 28 resemble AP Stat students. All right, so we're ready. So we do this, and we get 1 pair of numbers. we need to do this many times. In eighth period, I'm going to use third period's data. We had 21 people in the room and then 22 including me. So we did this twice. So we did this 44 times. Do this process 44 times. Count number of trials where 2 stat students are selected. And then we'll have to finish that thought out on the do step and on the conclusion. So there's our plan. I'm going to erase this and show you third period's results. So in third period, we did it 44 times and we got all this data here. Tried to make the trial number stand out so you don't mix it up with the student number. But what you need to do is skim through this and find where for both students we had stat students. So for example, right here. You know what? That's a typo. I just circled it and I realized, because that was my data, I realized I didn't get 2 stat students. That's supposed to be a 14 and an 81. Sorry. So just in case third period was watching, the answer would have been different. So never mind, not trial 1. But looks like that happens right here. And I'm going to pause it and count. All right, unless I'm missing one, those 3 circled trials are the only cases. Let me write it down. Circle trials where both students were 1 to 28. So, like, for example, on my first trial up here that I did, this one here, that first student was a stat student, but the second student wasn't, so I don't care about that one. All right, so it happened 3 times. 3 times out of 44. So what I do is I type that into my calculator and get a proportion to look at. And I get 0.0682. So 6%, 7% of the time, the results of the actual lottery happened in our simulation. So if you want to write it in percent form, you can. Two AP stat students were selected. All right, let's finish this out. Conclusion. And I'm out of room. So I'm going to write it in green on the left. So our conclusion with this is since 0.0682 is greater than the magic number 5%, 0.05. So remember the question of whether or not something is significant or not is if it's smaller than 5%. This one was not. This proportion is not, I'm saying this correctly, some people think backwards on this, significant. That means that it wasn't shocking. Let's write that also, not shocking. You know, like if in our trial it never happened and it was 0, or maybe it was 1% or 3%, then that would be shocking, and that would be cause for alarm. Maybe the lottery was rigged. This tells me it's not significant, therefore I am not alarmed about the results of the lottery. The lottery which selected 2 stat students, AP stat students, is plausible. I hope that's readable. All right. So it's a really hard conclusion to make because some people think backwards on it. But these results were not shocking. That is, if 5% is our significant marker. You can decide where the marker point is. Maybe it's 10%. If the level of significance was 10%, this would be shocking because it's smaller than 10%. It depends on what you see as rare or small or shocking, words like that. All right? That was all we did. See y'all later. Bye.